Okay, so the final lesson in this unit is really about angle relationships. We have a lot more we're going to add as the year goes on, but we're going to start with these basic 5. Vertical angles are angles that are opposite of each other on 2 lines that intersect. What do I mean? Well, I mean this green top is going to be congruent to the green bottom side. So whatever the top is, it will match the bottom, just like the left will end up matching the right. Okay. If we look at these 2 rulers, it'll demonstrate this. Okay. So the top is skinny, the bottom is skinny, and as I move them, the top gets bigger, the bottom gets bigger at the same rate. And then you'll notice the sides do the exact same. They start out big, they got small. Okay. Opposite sides on vertical angles will always match each other. All right, adjacent angles are angles that share a side. So here I have 2 angles, angle 1 and angle 2. Angle 1, well that's right there, those 2 sides. And angle 2, do you see how there's an overlap right here? Okay, adjacent just means next to, and these 2 angles are next to each other. They share a side. Complementary angles and supplementary angles both function the same. You just have to remember that complementary is 90 and supplementary is 180. So here's an example that looks like the old one, where I have 2 angles, but because they come together to form 90 degrees, this right angle, these are complementary. Supplementary angles are 2 angles that form 180 degrees, also known as a straight line. Now, these don't need to be next to each other. I could pull this one apart and do something like this, and I can say that, hey, this top angle, I guess that's gonna be 40 degrees, and the bottom one's gonna be 50. As long as they add up to 90, it's fine. Same deal here. I could pull these apart and have them add up to 180, and that would be fine too. A linear pair is special. A linear pair looks like this. Really just the thing I just drew. 2 angles that are on the same line that are supplementary. So you need 2 things to happen for a linear pair. You need them to be adjacent, you need them to be touching, and you need them to add up to 180. If you don't have either of those things, it's not a linear pair. You have to have both. So let's do some examples real quick. These 2 angles are not sharing a side, so they're not adjacent. Top and bottom, so we are vertical. I don't know if they're complementary or supplementary because it doesn't give me any numbers, and I just can't assume. So neither of those. And if it's not adjacent, not supplementary, it can't be a linear pair. Okay, 1 and 2 here, they are next to each other. They share this side, but they're not vertical because they don't make the cross. Now, it is tricky because these are actually complementary. If there is a box here and that box means 90, well, they're both on a straight line, so there's another box over there. So both of these angles together do add up to 90. They add up to 90, they can't add up to 180, and I don't have a linear pair. Okay, these 2 are next to each other. They share this side. They're not vertical. Vertical to 1 would be over here. Vertical to 2 would be up here. So they're not vertical to each other. They're not complementary because they don't make a right angle, but they do both fall on a straight line. 1 and 2 make a straight line, so they are supplementary. And if you have both of these things, adjacent and sub, then you, by definition, have a linear pair. These angles are next to each other. They're not vertical. They're not complementary. They're not supplementary. They're not a linear pair. This is an example of it doesn't give me enough information to make any guess about how much they're actually worth. All right, 1 and 2. Well, they're not next to each other. They don't share a side. Are they vertical? Do they go straight across? Yes, that will work. They are actually complementary because this tells me it's the same as this. And if there's a box down here, there's a box up there too. And if this is going to be the same as that, and I have two that are the same, then yes, they have to be complementary. Not supplementary, and not a linear pair. Last one, these are not next to each other, they don't share a side. They are vertical though. If there's a box here, there's a box there. There's also a box here, and a box there. So every one of these is going to be worth 90. So 90 plus 90 is not 90, but it is 180. I have supplementary, but I don't have adjacent, so I don't have a linear pair. Okay, let's go quickly through the examples. You have to find their angle relationships. The 112 and the x, well, that's a vertical pair. I got a top and a bottom. So whatever the top is, the bottom is going to match that. Here, I have a box, and I know a box is worth 90. If I have the whole thing worth 90, I need to take away the ones that I have to find out how much I'm missing. And here I have a straight line. Well, straight lines are worth 180. So let's take away 124, and let's get what we're missing. 56. Number 4 you can get creative with. You can solve this a couple different ways. I like to view vertical angles first because those are easy for me to see. 43 is on the right here. Well, if I go straight across, 43 is going to be y. And then I can see that y and x make a straight line. Straight lines are worth 180. So x is 137. But now what's vertical to x? Directly across is z. And you could have done the same thing here, 43, hey look, another straight line, and do that math again to get down here. But you don't have to do that twice. Okay, so if you have a box here, and this is a straight line, then you also have a box there. So whatever z is, well, we're going to find 90, take away 72, it's going to tell me z is 18. It might be tricky to see, but y is vertical to 72. Let me highlight that so maybe we can see it better. If this is y, that's 72, and we can see that that is exactly across from each other and they are equal. So that one is going to make this 72. And I see that y and x make a straight line. So 180 take away 72, 108. All right, word problems. If 1 and 2 are vertical angles, the measure of 2 is 105. What's the measure of 1? Well, we could draw a picture if we need to. Here's an example of vertical angles. I'll call this angle 1, this angle 2. And it said 2 was 105. Well, we know that vertical angles will be the same. We don't need the picture if you don't need to know. You could just know the definition. Hey, vertical, gonna be the same, so it's gonna match. But sometimes the pictures help. A and B are complementary. Complementary means 90. So that means them added together make 90. 90, take away the 42 I have to find out what I'm missing. P and Q, same deal, they're supplementary, that means 180. 180, take away the part that I don't, or the part that I have, to figure out what I'm missing. And 1 and 2 here form a linear pair. That means they look like this. 1, 2. If 1 is 113, what's 2? Well, linear pairs are also supplementary. They add up to be 180 because they make a straight line. So 180, take away 113 gives you 67. All right. Now, those are easy. Those are with the definitions. I wish they all were that easy. Now we have some algebra. If PQT, that's this part here, is that. And SQR is this down here. What's the measure of SQR? Well, first I need to figure out their angle relationship. The green to the blue, it looks to me like they're vertical, top and bottom. So we're gonna have these two things equal to each other, so we'll set them equal. Put the smaller variable first, give something back. What is that, 72? 72 equals 3x. Divide by 3, x equals 24. Okay, that's important, but that's not what we wanted. We wanted to know what the blue one is, so let's substitute this in. 6 times 24 minus 25. Well, that's gonna be 144 minus 25, or 119. Okay, still just gonna pick these apart by their definitions. It's the best way to go about these when you're confused. A is perpendicular to CD. And I remember that perpendicular means you have a right angle that's being formed. So there's a box here and a box here. That might be important. Okay, DCE. DCE is this top one, C to E. And ECB is this one. Okay. So, yeah, actually the perpendicular was really important because I know that the green and the blue together make a box. They make 90. So I will add the green to the blue and I'll set it equal to 90. 8x plus 10 equals 90. I'll subtract 10. 8x equals 80. X equals 10. Well, that's not bad to solve for. But it didn't want x, it wanted the green. So that's going to be 7 times 10 plus 2, which is 70 plus 2, 72. Last one for this page. All right, what we got? KNM. K to N to M. That's this big one on the right. Okay. MNJ. MNJ. That's this. Find the green. Okay. Well, I see that the green and the blue together make a straight line. And straight lines are worth 180. So I will add these two together and set it equal to 180. 12x minus 24 equals 180. X equals 204. Divide by 12. X equals, what is that, 17? 17, yep. Okay, again, X was important, but it's not what we need. We want to solve for the green. So 8 times 17 minus 5, that is 136 minus 5, 131. All right, we're only going to do a handful of the ones on the last page here. If DEG is this, DEG, that's this here. And GEF, G to E to F, boom, this top one here. last but not least, DEH is that. Solve for x and y. So now I have two variables. Well, I have to pick one to solve for first. I can only actually solve for the x because I have two of them. This one has an x and this one has an x. I can use them to compare against each other. There's only one y, so there's nothing I can do there. I gotta figure out x first. So let's compare the blue and the green and see what their relationship is. Well, the blue and the green make a straight line. Straight lines are worth 180 when you put them together. So add these together. 12x minus 12, set it equal to 180. And you can do the two-step on this. Divide by 12, and we can get x equals 1, 2, 6, so 16. Okay, that's x. I need to get y. Well, let's look at what y is. Y is this purple one down here. So I need to either form a straight line with the green and the purple, or I could use that purple is vertical to blue, and then they're gonna be the same. That's what I'm gonna do, because I like vertical angles better. If you wanna use straight lines, you go for it. But I wanna figure out what the blue is actually worth. 7 times 16 minus 8. Okay, well that is 142. Is that 104? So that is 70 plus 42. Yep, 104. Okay, so the blue is 104. That means this purple, which is vertical to it, is also 104. I'll take what the purple is, this right here, 9y plus 5, and I'll set it equal to the 104. The 5. 9y equals 99. Divide by 9, y equals 11. Okay. So I had two variables, but I had to use two different types of angle relationships to figure that out. 14 and 15, I'm not going to do. They're complementary. That means if you add them together, you set them equal to 90. They're supplementary. Add them together, set it equal to 90. You can solve for your variable, and then you can plug it back in. We've done lots of examples like that. I want to spend time doing questions like 16 and 17, because these are confusing. 1 and 2 form a linear pair. So that means we have two angles, angle 1 and angle 2. And they make a linear pair. So they sit on the same line and they're next to each other and they're both worth 180 together. Now this sentence is confusing. The measure of angle 2 is 6 more than twice the measure of angle 1. What does that mean? Well, here's your shortcut. You find the angle that is second in the sentence. The measure of angle 2, that's the first mention, is 6 more than twice the measure of angle 1. 1 is the second one that is mentioned in the sentence. That second one, angle 1 here, we're going to call that x. The other one, measure of angle 2, is being compared to angle 1. So I need a baseline. I have to call this x. But it always works out that it's the second one in the sentence. Okay, so I have my label for measure 1. I need to figure out what this one is. Angle 2 is 6 more than twice this. Well, how do I write twice this? That's 2x. How do I write 6 more than twice that? Well, 6 more is adding. So angle 2 is 6 more than twice x. Okay. Now that can be confusing. I totally get it. Practice makes perfect on those, but they do make a straight line. So I'm going to add these two things together that I have in red, and I'm going to set it equal to 180. 3x plus 6 equals 180. Subtract 6. Divide by 3. X is 58. It didn't want x would have been measure 1, because we called that x. It wants measure 2, so I need to come over here and I need to plug it in. 2 times 58 plus 6. That's going to equal 112. No, 122. That's going to equal 122. Okay, let's do 17. It's very similar, same example. Now they're complementary. Okay, so let's draw something like this maybe, where we have a box. J and K are complementary. Now here's the complicated sentence. The measure of J is 18 less than the measure of K. Well, which angle was mentioned second? Let's call this one J and this one K. K was mentioned second. K is going to be X. All right, J is 18 less than K. So less than is subtracting. Find the measure of each angle. All right. Well, I know that J and K together make 90 because complementary means 90. So let's add these together. 2x minus 18 and set it equal to 90. 2x equals 108. X equals 54. Okay. So x is 54. It wants me to find the measure of each angle. Well, I called K X. I just chose it to be X. So that means K is worth 54. And J is our X minus 18. So 18 less than 54 is 36. Okay, I am going to do one of these. Let's do number 19. All right. I chose this one because it has the word bisect in it. Bisect means to cut in half. So this line here, MO, this ray, is cutting this angle in perfect half, meaning that this little piece is going to be the exact same as that piece. PMN is 74. PMN, that's the whole thing. OMN, that's that much. And that's exactly half of it. Find the measure of x. Okay, well there's two ways we can do this. I know that the whole green piece is worth 74. I also know that the blue piece is exactly half of the green piece. So if I wanted, I could just double up this blue and then it would be exactly equal to the green. So I could take the blue, double it up, and then I could set it equal to the green. And then I would subtract the 14 from both sides, and I would divide, and I would get x is 15. That's one way to do it. The other way to do it is kind of the same logic but backwards. I know that blue is exactly half of green. So I could take this green, cut it in half, and then I could just set it equal to the blue. Either way, you get the same answer. So there's lots of different ways to solve these if you know what's going on.